hydrocarbon that we're doing. So I have a link there I've put out there. Again, this is online. So this is STOIB calculator. Credits to the authors of this tool. So online here, I imagine that we have 400. I just type it in. Let's just say we have 500 acres of reservoir in terms of reservoir dimension, thickness times length times width. Okay, and then let's imagine that the thickness of that interval that is able to hold hydrocarbon, let's say, is 100 feet. Okay, let's imagine a porosity. Again, imagine the porosity is, okay, let's say 40%, 45%. In other words, the rock is so porous that 45% of that volume of rock is pore spaces or open spaces that oil or gas can occupy. In this case, oil. Okay, and then let's again imagine that oil saturation is, in this case, 75%, and shrinkage factor is 0.64, 1 over B sub O. If you do a calculation, if you run the calculation, it's giving us 83.7 or 3.8 million barrels of oil. Now let's imagine that same rock, okay, that same rock has been buried to a much deeper elevation where, let's just say, I don't know if I can sketch on the screen. Okay, no, I can't sketch on the screen now. All right. So at a shallower elevation, porosity was 40, but through time, it becomes very compacted and it gets buried. And the porosity has now been reduced to, let's say, 25%. So let's change this porosity from 45. Remember, your volume was 83.8 million barrels. And then the porosity is now, let's just say 30 by burial or by compaction. And then I run the calculation again. You see your volume has reduced to 55.9 million barrels from what it was 70 something to 55. So you can imagine what this does to our volumes, you know. So that's why putting it together, a very detailed understanding of how processes can impact your reservoir quality really helps us in our modeling, really, okay, and our understanding of how much the reservoir can hold in terms of volume and in terms of transmissibility of the hydrocarbon presence. Okay, so rounding off, I know there will be questions. I will take the questions. What are the concluding thoughts? First of all, reservoirs are subjected to many or multiple phases of change from when they are birthed. In other words, from when they got dislodged from their source, and then they keep moving through, they are transported by different means, all the way down to their final destination. And I said, not really. The changes don't even stop there. The changes continues even after the reservoir has been laid in its final deposition, in the final environment. Why? Because like you saw, there could be plate movements, there could be compression, there could be space issues that will cause the reservoir to either get folded or squeezed or stretched in the case of extensional movements. Okay? And there could also be some changes like we saw, biological evidence of activity, like biological activities where the fossils or this past life can also enhance or degrade the quality of the reservoirs. And in some other cases, chemical changes due to either squeezing or so. There might be some kind of change, dissolution of minerals or some of these compounds might also enhance the reservoir or make it poorer. Okay, so second point is that hydrocarbon storage capacity for most reservoirs depends largely on the final preserved connected pore spaces. Not the initial one that you saw. If you remember the video we watched, not that initial sand that were all friable and very loose. No, that's like very porous. But as it gets buried and as it gets squeezed, the property reduces, the porosity, the connected pore spaces reduces, and ultimately some other processes can even further reduce it. And then what you get is what is able to keep hydrocarbon at the end of the day. In summary, proper 3D characterization of reservoirs, proper, analysis of reservoirs is very key, and it's a prerequisite for, accurate estimation of how much hydrocarbon you have in your reservoir, as well as making decisions regarding well placement and assets development planning. Like I talked about number of wells, I talked about how connected are these hydrocarbon traps. It's very important because it will determine whether you're using one well or multiple wells, whether the well will produce for 10 years or 50 years or not. Okay, so this is just my quick thoughts on how the reservoir starts from the onset, where it begins as very loose and very unconsolidated, and then through experience of transportation, changes in different environments and different conditions, it gets altered to its final domain, where it's sometimes even further changed to have a new property that now determines how much of oil and gas it is able to hold in place. So this is just what I have to share. I know I tried to race through because of time, but I hope it was worth your while.